Hello friends, welcome to my channel Tech Buzz with Pradeep. I hope you are doing great. Today we are going to discuss very important topic that is MLOps, system architecture and design. This is very much important to understand how a MLOps pipeline can be created and how the ML model will be deployed efficiently into the production. That is why I am here with this video after a lot of requests from you guys. So we will understand MLOps system architecture. Okay, so we will come to the MLOps system architecture. So MLOps system architecture are composed of two environment, development environment and production environment. So in the development environment, what we generally do, we used to do the rapid experimentation with the help of the PyCaret tool, and we used to compare the models based on precision recall and inference score, and we used to choose the best model, and then training pipeline will load that particular model to train further. So in this way, the development environment and production environment will be integrated. So the job of the production environment is to operationalize the best model identified from the development environment. That is what we discuss. We will discuss in a broader way into the next slides. So here we can see the production environment where we are having the data pipeline, training pipeline, testing pipeline, inference pipeline, and model and monitoring pipeline. So these four pipelines, which are which are into blue color, these are the continuous integration and deployment pipeline, and the fifth one is the continuous learning and monitoring pipeline. And what I have discussed in the previous slides, that in the scientific dev environment, we used to train the model, compare the model, and identify the best model for the training pipeline. And further steps will be followed. This is the comprehensive view of the diagram what we have created into the previous slide. Here we can see the broader view of the data pipeline, training pipeline, testing pipeline, inference pipeline, and data monitoring pipeline. Inside to a data pipeline, we can see different stages like data integration, data preparation, feature engineering, and training. We have different stages like model training, model validation. In testing pipeline, we used to do unit and integration testing and UAT testing. And inference pipeline, we used to deploy the model, and then particular model will be handled to the for monitoring into the production, and it checks about for the data and model drifting. If any issues arises, then alert will be triggered for further action. So we will discuss these things, what are the different events based on deviations, and what are different actions. So we will discuss this model and data drifting in the next slides. Okay, so as we discussed, these are the 5 pipelines through which we can just create the MLOps pipeline. And we will discuss all of these pipelines one by one. So first one is the data, first two actually, for data and training pipeline. So these components focus on automating model training by converting the code developed in the notebook to the Python script. So basically, when we write the code, we used to do a basic coding is using Jupyter notebook. Jupyter notebook is very much helpful to visualize the data, and we can do the very easy operation, and we can see the outcomes through visualization. So with automation coupled with using feature stores, the data and training pipeline can run whenever there is any change in live data. So before understanding this line, we need to understand something from this diagram. So before data ingestions, we used to go for the EDA, exploratory data analysis. While EDA, we understand the pattern from the given data using visualization. Like here we can use the pandas, profiling, matplotlib, and the seaborn, and we can understand the data behavior from a graph. Then data will be ingested and data will be pre-processed and feature engineering will be done. And whatever the feature extracted will be stored inside into the feature store. We can use SQLite as a feature store because it is light databases and it is frequently used. And these feature stores, what we have extracted in the data pipeline, that will be very much helpful for the model training inside into the training pipeline. For the automations in this stage, in both of the stages, we use the Airflow on premises. I'm not talking about the cloud managed services. So here we are discussing mostly for the on premises, how to develop the MLOps pipeline on premises, and what are the open source tools can be used for the automation. So the Airflow is the automated automation tool for on premises. Coming to the next pipeline, that is the testing pipeline. So once the model will be finalized into the training pipeline, that model will be registered very first inside into the MLflow model registry. So first the model will be validated with the unseen data for the model, and after that, that model will be sent for the unit and integration testing using PyTest. Further, it will be promoted to the staging stage, and inside into staging stage, we use to test the model by mimicking the live data for user acceptance testing, and then the model will be promoted to the production stage. So in this way, testing will be done, and the benefit of this testing pipeline is like it manages the different version of the model in each of the staging so that the model can be recovered from the previous stage if something goes wrong. So now we will come to the content here. The tests applied here are the unit tests, integration test, and user acceptance testing, right? What we have discussed. If the model passes all these tests, it can be moved to the production. That is, it can be used for making inferences and predictions. So here we are talking about once the testing will be done, it will be handed over to the inference pipeline for making the predictions. Therefore, testing helps in continuous integration of the model trained on new data. Okay, coming to the next slide. Inference pipeline. Once model will be tested, then it will be sent for the inference pipeline to do the deployment of the model automatically. For that, we use the fast API with MLflow server. So here we used to do the inferences on the live data. This is the responsibility of the inference pipeline. So in this stage, once the model code passed all the tests, you will go ahead and deploy the model for serving predictions. So in this stage, we can use few of the open source tools like Streamlit, MLflow, serving for quickly deploying the models. Right? Okay. Now we are coming on the fifth pipeline, that is data and model monitoring pipeline. This is the very important. This is the very much important pipeline which is capable of identifying the data drift and the model drift. What happens actually with the patch of time, data behavior can change. Data can be changed. The behavior of the user may also be keep changing. So in these cases, there's a lot of chance of data drifting and model drifting with the patch of time. So we have to be very careful about any deviation into the data, and if anything happens, we need to inform the data drifting and the model drifting to the stakeholders to manage it. Okay, so in this case, if anything happens wrong, like data drifting or the model drifting arises, then we have to trigger an alert to the stakeholder that these things are happening, and the pipeline should have the capability to manage such kind of the data drift and the model drift. That is what we will discuss into the next slides. Before moving to the next slide, in this we will discuss what has been described over here. In this stage, we keep tracking the model performance and ensuring that the model doesn't go stale. The trigger connected to this component decides what action to take: model experimentation or the model retraining. This is very much important, guys. How to manage the model drifting and the data drifting. The tool used in this stage for monitoring any data drift is evidently AI. Evidently, AI is the monitoring tool we can use on premises to identify data and model drifting into the pipeline. Here I wanted to show you in this slide, once the model from the testing pipeline will be handed over to the inference pipeline, it will be deployed into the production and it will be handed over to the data and model monitoring pipeline, where monitoring will be done with the help of the evidently, and if any data and model drift will happen, alert will be triggered based on the deviation of the data. What are these deviations? Deviations means deviation between the older data and the new data. Okay, so if the deviation is very less, then we need not to do anything. But suppose if the deviation is between 5 to 8%, in that case, we have to start from data pipeline and we have to move to the training pipeline. Like we have to trigger the data pipeline and training pipeline again. But if the deviation is higher side, like more than 10%, in that case, we have to start to play with the model. In this case, we need to just identify the new model for the new data. And then we can retrain inside our training pipeline. Once the model will be received, it should be trained by the new data. And here we can just do the retraining of the data on the new data based on changing the hyperparameter or not changing it. And all the logs of all the experimentation will be logged inside into the ML flow tracking server. And after the model will be identified, it will be registered inside into the ML flow model registry. And here the validation testing, unit integration testing, and UAT will be done. And the final model will be deployed here, and that particular model will be sent to the data and model monitoring pipeline for continuous learning and testing. And if anything happens, then it will be triggered. It will trigger the action what to do. But remember, guys, these deviations are very much important, and that should be decided by the business people. The same thing I have described over here. What what will be the deviation, and what are the different actions we need to take correspondingly. Here 1 to 2% deviation, no action will be required. 5 to 8% deviation, the data and model training pipeline are triggered for retraining the model with new data. But if the deviation is more than 10%, this can occur when user behavior change drastically. In such scenario, you must go back to the development environment to perform data and model experimentation. And this deviation value may change, and based on that, the business people would decide what to do. So we are not deciding it. It will be decided by the business people corresponding to the different use cases. Okay. So now we are coming to the summary part, what we have discussed. So quickly we will just summarizing it. Into the first stage, what we are doing, create a development environment for performing rapid data and model experimentation. This will help you in identifying which model performs the best for the given data. Once you have finalized the model, you need to automate the entire process by converting code into a notebook Python script. The entire automation process can be done by building DAG through Airflow. So DAG is the directed acyclic graph. It decides the actions. What will be the action? Like second will be executed after first will be executed, and the third will be executed once second will be executed. Or how the order may change also, but the DAG will identify what event should be executed in what scenario. And this DAG will be implemented through the help of some open source tool like Airflow. The third one is to bring in the characteristics of the CI/CD. You need to add different protocol for testing the different component of the data and training pipeline and it working as a whole. So this is nothing. This is MLOps pipeline is a CI/CD pipeline in which we can see two extra operations: machine learning operations, uh, mod, sorry, in the third point, if what we are just trying to say, like Ops is just a CI/CD pipeline, just like DevOps. But in MLOps, we have two additional operations: model operations and data operations. To manage the operation regarding to the data drifting and model drifting. That is what we discussed in the previous slides. If anything happens, then we have to trigger the alert, and corresponding to the situation, we have to take the action. But this is automated CI/CD way. Coming to the fourth, finally, you need to build a continuous monitoring system for tracking any model stillness. Right? We have to keep checking continuously whether the model is going to be still. It can be identified with the help of the deviation. That is why we are having the standard of finding the deviations, and based on the deviation, we are just going to take the action. So, so guys, I hope you like this video, and this video is very much informative for the guys who are the MLAI developers and architects. It is giving you the comprehensive view of creating the system design for MLOps pipeline. Thank you guys. We will meet into the next video soon. Bye.